Measures of dispersion. When we study about a data, then we basically look at the central tendency like the mean, median, mode, but not all the time those information is enough. Let's look at the following two data, sample data. We have one data, let's say data A, that has the numbers 28, 29, 30, 31, 32, and another data set points, data B, which got the sample points like say 10, 20, 30, 40, and 50. If you want to study about this data, then you want to find the mean, median. So for data A, the mean and the median, if you add all these 5 numbers and divide by 5, then mean is 30. So is the median. Okay, and data B, if you add all these 5 numbers, divide by 5, you have the same mean, and this is also the mid value, so median as well. But look at these two data samples, they are totally different. Though they have the same mean and median, they are totally different. Okay, these entries in this data B are more spread. Then we want to study how far they are from the mean, and one of the measures is the standard deviation. At the same time, we can find the range. That's too easy. And so range of a data set is the largest value minus smallest. Okay, if the range is asked, then you can find the largest value minus the smallest value. Okay, and this does not give you a lot of information. So what we do, we find the standard deviation. Standard deviation. Okay, so how do you find the standard deviation? Suppose we have n sample points. Suppose we have n sample points, n sample points of a big data. Let's say ex1, ex2, ex3, all the way to exn, and their mean, when we find the mean or the average, is x bar. Okay, then the sample standard deviation, sample standard deviation, we denote by s, is given by or calculated as follows. What we do is we subtract, we find the difference of the data set points, x is x1, x2, x3, or xn, and subtract with the mean. Okay, find the deviation of the data point from the mean, and we square it. Okay, then we sum all of them, that's sigma, sum all of them, and we divide that by n minus 1, where n is the number of sample points, and divide by n minus 1 and take the square root finally, and that is the standard deviation, sample standard deviation. Okay, so we divide by n minus 1. If this is a population model and we have all the population, all the data points, and you can divide by n, but in this book we are using n minus 1. So let's do one example. Let me write down the example and I'll come back. Okay, here's example 1. Find the standard deviation of the sample data points. So we got data points 7, 9, 18, 22, 27, 29, 32, 40. So we want to calculate the standard deviation. Here is the formula. So first of all, we need to find the mean or the average. Okay, let's find the mean or average. We denote by x bar. That is, add all of these entries and divide by 1 2 3 4 5 6 7 8. Okay, add all of these numbers. That's 7 plus 9 plus 18 plus 22 plus 27 29 32 plus 40 and divided by 8. Use your calculator, you're gonna get 23. So 23 is the average. Now next we want to find, I would like to draw a table and calculate the standard deviation. So x, that's the given data set points, so we have 7 9 18 22, then 27 29 32 40. Next we want to find the deviation from the mean of these data points. So x minus x bar, where x bar is the 23. So 7 minus 23, 9 minus 23, 18 minus 23, negative 5. Similarly 22 minus 23, minus 1. 27 minus 23, that's 4. Then 6 9 40 minus 23, that's 17. And look at the formula over here. Then this is the deviation from the mean. We square and we find the sum. Okay, in the next column, square these entries, x minus x bar. This is the deviation of the entry from the mean, square. Negative 16 is squared, so that's 256. 14 is squared, 196. 25, 1, 16, 36, 81, that's 289. Okay, and look at the formula. Now we find the sum of these deviation square deviation. So we find the sum. So let's add these numbers. When use your calculator, add all of these, you get 900. Okay, so 900. Then we divide that sum by n minus 1 here. This is 900 in our case, and n is 8. 8 minus 1, this will be 7. So we divide 900 by 7. Then standard deviation is square root of sum of these deviation squares, that's 900, divided by 8 is the number of sample points. 8 minus 1, 7, and take the square root. So divide 900 by 7 and take the square root. This is about 11.3. Okay, so next let me write down another example and I'll come back. Next example, find the standard deviation of a frequency distribution. So we have value 2 3 4 5 and frequency. 2 comes 5 times, 3 comes 8 times, 4 10 times, and the value 5 comes twice. Okay, so total we have 5 plus 8 13 12 25 entries in this case. Okay, so let's do the following table. It will be about the same. If you, that's 5 8. Okay, if you spread all of them like 2 2 2 2 2 5 times, 3 3 3 3, right, 8 times, 4 4 4 10 times, and 5 5 5 5 5 twice, and then you can do the previous step, previous example, but that's tedious. So we're gonna do the following. So Ax is the given sample data values, so 2 3 4 5. Frequency 2 comes 5 times, 8 10 and 2. First we need to find the average or the mean of this data. For we find x times f, multiply the data with its frequency. So 2 times 5 10, 3 times 8 24, 4 times 10 40, 5 times 2 10. Now we sum this numbers, that's 84, and we divide the frequency, sum of the frequency, 25. Okay, when we divide 84 by 25, we get the mean or the average of this frequency distribution. So let me find over here. So x bar is, in fact, in this case, mean is 84 divided by 25, which is 3.36. Okay, now like previous step, we want to find how far the deviation of these entries from the mean, because our mean is 3.36. so we find x minus x bar. X is the data set points, x bar is the mean. So we are trying to find the deviation of these data set points from the mean. So 2 minus x bar is 3.36. so this x bar is in fact 3.36 that we just found. So x is 2 minus 3.36, so negative 1.36. 3 minus 3.36, that's negative 0.36. Similarly, 4 minus 3.36, 0.64. 5 minus 3.36, 1.64. Like in the previous step, we want to find the squares of these deviations. This is square, x minus x bar square. So negative 1.36 is squared, that's 1.8496. 0.36 is squared, 0.1296, 0.4096, 2.6896. Now we would like to multiply these deviation squares with the frequency, because these deviations, the first deviation comes how many times? 5 times. Second deviation comes how many times? 8 times. So we want to multiply with the frequency. So f times this deviation square. So 5 times 1.8496, that's 9.2480. So 8 times 0.1296, so 1.0368, 4.0960. 2 times 2.6, so 5.3792. now we add these numbers. Okay, that is 19 point, if we add all, 19.76. these are the squares of the deviations, and then we multiply by frequency of, because 2 comes 5 times. Now we divide this 19.76. okay, that's on the top, and we divide by number of n, that's the 25 minus 1. So we divide by 25 minus 1, that's 24. Okay, so the standard deviation is equal to square root of, or you can just denote by s, 19.76 divided by n minus 1, so 25 minus 1, 24. Divide this by 24 and take square root, so this is about 0.91. Final.